Hello everyone. Today I'm going to do a presentation on application of dynamic theories on lazy Susan table mechanism. And this presentation is for EMM-3105 dynamics and it will be done by me, Ishan Mitra Haldar, and my metric number is 201390. I will start with the introduction. The lazy Susan table was invented in the 18th century by one Western scientist, and it was very popular at that time, but later on by 1918 the Century magazine already told or published in their magazine that it was already out of fashion, but still till this date it is being hugely used in the southeastern region of Asia, which is largely known by Japan, China and countries like those. After that we'll move into the mechanism, which is how this lazy Susan table works. As we can see in the screen, this is the main table, this is the connecting rings, these are the ball bearings that will be actually rotating the top table. Then we actually use one middle bar to keep the whole mechanism intact. After that there will be this middle table which will actually rotate, and lastly the top table which will rotate all the dishes that are placed on it. Now we see how the lazy Susan table will actually rotate when we push it or give force to it. As you can see, if we push it, it will rotate in the direction of the force. Therefore, that was the mechanism for the lazy Susan table. Now we proceed to the theory part. The box number 1 is actually indicating the relationship between torque, mass moment of inertia and angular acceleration, which is angular acceleration equals to net torque divided by the mass moment of inertia as it is shown by the red color in box 1. Then for box 2 we see the linear impulse linear momentum equation that is being displayed in here. For box number 3 we can see the angular impulse angular momentum equation that is being displayed in here. Now if we omit the middle parts of both of these equations, which is actually consisting the summation and the integration part, we will get the linear conservation of momentum equation and angular conservation of momentum equation. Use these theories that we learned right now. We will proceed with the examples using those theories. The turntable of a lazy Susan has a mass of 1 kg, radius of gyration of 25 cm, and it is turning freely with 2 radian per second angular velocity. And when there is a plate of 500 gram placed on it that has a diameter of 20 cm, we have to find the final angular velocity of the turntable, and what we are assuming in this equation or this question is that we have to find the angular velocity after the plate stops slipping on the turntable. Now in the left we can see the free body diagram of the whole problem, and this plate is having mass, radius, and this main table is having radius of gyration, mass, and also the rotation. We have to find the final angular velocity when the plate stops slipping. We use the angular conservation of momentum theory to find the final angular velocity, which is h1 equals to h2. If we see that there is only rotation for both of these, so there won't be any linear parts, and we will only have the mass moment of inertia and the rotation per second as the values. For the initial one we only have the tables, but for the final one we have the table and also the plate. So after we plug in all the values, we get that the final angular velocity will be 1.923 radian per second. Now The summary of what we have done. At first, I have explained what is a lazy Susan table for those who actually don't know what a lazy Susan table is. And lastly, we saw some dynamics equations that we can apply on the lazy Susan table mechanism, and also we have seen some examples of the application of those theories that we have learned. Lastly, the scopes of this lazy Susan table is very big. Firstly, as you can see on the left, there is the cockpit of the aircraft, and this lazy Susan table can be used in this cockpit as a device to place the switchboards, because the cockpit is a very space managing place where the placement of the switches are very important. So we can use the lazy Susan table to place a lot of switches in one place. Also, we can integrate voice command with it so that the pilot doesn't have to actually rotate it itself. But some may ask me, why would we use the rotating disc when we are actually having the voice command? But the problem is, if somehow the voice command fails, then what? Then the pilot needs to rotate the disk, and for that we can use the lazy Susan mechanism. And as you can see in the right, it is a very lovely scenery of a buffet. We know that by 1918, the Western region wasn't using the lazy Susan anymore, but it is still being used in the Southeastern Asia. So we can do research on if it can be implemented on other countries as well. That will be all from me. Thank you so much for watching this presentation. Have a nice day.